Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Maximum product subarray, Leetcode 152. This problem is part of Blind 75, a curated list of essential coding interview questions. You can find the full list linked in the description below. Be sure to check it out. Now to the problem. In this problem, we are given an integer array nums and we have to find a subarray that has the largest product and we have to return that product. A subarray is an array consisting of contiguous elements of the array, and the test cases are generated so that the answer will fit in a 32-bit integer. Then in example 1, for the given nums array, the maximum product is 6 coming from this subarray. Similarly, in example 2, the maximum product we can get is 0 from this subarray or even this subarray. Now in terms of solution, the simplest way to solve this problem is to try all possible subarrays by running two nested loops, where the first loop, say with iterator I, starts the subarray and the second loop, say with iterator j, ends the subarray. For example, we can form the subarrays like 2, 2 minus 3, 2 minus 3 minus 2 and so on. And then we start the subarrays from minus 3. So it will be minus 3, minus 3 minus 2 and so on for all the subarrays. And then for each subarray, we calculate the product of its elements and the maximum among them will be our answer. Now the time complexity of this approach is O of n square because of the two nested loops needed to generate all possible subarrays, which is inefficient. And to improve upon this quadratic time complexity, let's look at some cases. Case 1 can be when the array contains only the positive numbers, like this one. And now let's evaluate how the product evolves. So first element we see is 2 and the current product will be 2, which is also the maximum product we have seen so far. Then if we extend the subarray, the product becomes 6, which is more than the previous max product of 2. Hence, the max product now is 6. And if we include 4, now the product of this subarray is 24, which is also the maximum product. And finally, when we take the full subarray, then the product becomes 120, which is the maximum product we have seen so far. So if the array contains only positive numbers, the product of a subarray will keep increasing as we include more elements. And adding additional elements to the subarray will always result in a larger product. And this case was straightforward. Now let's look at case 2, when the array contains only negative numbers. Let's again track how the maximum product evolves step by step. So we start with the first element, which is minus 2, and the current product of this subarray will be minus 2, which is also the maximum product we have seen so far. The next element we see is minus 3, and when we extend this subarray, the product of the subarray flips and becomes plus 6, which will also be the maximum product we have seen so far. Then the next element we see is minus 4, and if we extend the subarray, the product of this subarray will become 6 into minus 4 equal to minus 24, and we can see that the product flips the sign again. So depending on the number of negative values we have seen so far, the product alternates between positive and negative. Even count of negatives result in a positive product, while odd count results in a negative product. Also, at this point, a better subarray is minus 3 minus 4 with the product plus 12, which surpasses the previous maximum product of plus 6. So how can we get that? We can get it by including the minimum product we have seen so far. For example, before encountering minus 4, the minimum product we have seen so far is minus 3. And now, as soon as we encounter a negative value of minus 4, multiplying it with the minimum product flips the sign and can yield to a maximum product, which is plus 12 in this case. So whenever a negative element is encountered in the array, multiplying it with the minimum product may yield the largest product due to negative to positive sign flip. Now let's solidify this idea by considering another number. Suppose the array also had the element minus 5, and after processing the number minus 4, the maximum product we have seen so far is 12, and the minimum product becomes 6 into minus 4, which is equal to minus 24. And since minus 5 is negative, multiplying it with the current minimum product of minus 24 flips the product with positive value plus 120. This becomes a new maximum product as it surpasses the previous value of 12. Now because we are tracking both maximum and minimum products, there is no need to track the sign of the element explicitly. We can simply multiply -5 with both maximum product of 12 and minimum product of -24, resulting in values -60 and 120 respectively. And the new maximum product will be the maximum of the two products, which is -60 and 120, which will result in maximum product of 120. Similarly, we can calculate the minimum product by taking the minimum of these two products, which is the minimum of -60 and 120, which will be -60. Similarly, had it been +5 instead of -5, then the maximum product would have been 5 into the maximum product we have seen so far, which is +12, which is equal to 60. But again, we don't have to rely on the sign of the number. We can also calculate the maximum product by taking the maximum of product of current number into previous maximum product and minimum product, which will be equal to maximum of 60 and -120 equal to +60. Similarly, the minimum product will be minimum of the two products, which will be equal to -120 in this case. So to summarize, to calculate the maximum product subarray efficiently, we need mainly two variables, which are maximum and minimum products we have seen so far. And now let's look at the final case when the array also contains a 0. So as soon as we include a 0 in a subarray, the product immediately becomes 0. So 0 acts like a breaker, resetting the running product to 0 and forcing us to evaluate the maximum product from the next element onwards. In essence, 0 splits the array into segments. For example, the product of this subarray is 6, which will be the maximum product we have seen so far. Then we encounter 0. So we reset our running product to 0 and start a new subarray from the next element, which is -2. Now one way to reset the products to 0 is by explicitly checking for element 0. But we can also reset the products dynamically. For example, for the maximum product, we can take the maximum of the product of the current number with the maximum product and the product of the current number with the minimum product like we were doing earlier. But this time we also take maximum of the current number as well. So this way, for the maximum, we will take maximum of 0, 0 and -2, which will be equal to 0 in this case. Similarly, for the minimum product, we will take minimum of the element and the product of the element with the minimum and maximum product, which will be equal to -2 in this case. Now the next element we encounter is -3. Hence the maximum product now becomes +6 and minimum product becomes -3. Then the next element we encounter is 4. Hence the product of this subarray is 24, which is more than the maximum product of 6 we have seen earlier. So the max product now becomes 24 and we encounter 0 again. And finally the last subarray we see is -1, which is smaller than the maximum product of 24. So overall maximum product remains +24. Now let's quickly apply the learnings from all the cases and go through this example. So we will be needing the two variables, maximum product and the minimum product. And throughout the iteration, we will be also tracking our answer. Initially, we can set the maximum and minimum product along with answer equal to the first element, which is equal to 2, and start the iteration. So the next element we see is -3. Now the maximum product will be equal to maximum of the current element, which is -3, and the product of the current element with the maximum product we have seen so far, which is -3 into 2 equal to -6, and the product of this element with the minimum product we have seen so far, which is again -3 into 2 equal to -6. So the maximum of these values will be equal to -3. Similarly, minimum of these values will be equal to -6. But the answer says 2 only. Then the next element we encounter is 4. So the maximum value here will be equal to maximum of 4 and the product of the element into the maximum and minimum products, which will be -12 and -24, which will be equal to 4 here. Similarly, the minimum will be equal to -24. And since the maximum is more than answer, the answer becomes 4. Then the next element is 0. So the maximum and minimum becomes 0, but the answer stays 4. Then the next element we see is -6. So the maximum stays 0, but the minimum becomes -6 and answer stays 4. Then the next element we see is -3. So here the maximum product will be equal to maximum of -3 and product of this element -3 with maximum and minimum product, which will be equal to 0 and 18. So the maximum product now becomes 18 here. Similarly, the minimum product now becomes minimum of these three values, which will be equal to -3. And since the maximum is more than the answer, our answer now becomes 18. And finally, for the last element, we have to take maximum of the element itself and its product with minimum and maximum, which will be 90 and -15. The maximum value we will get here is 90. The minimum value will be -15. And since the maximum product is now more than answer, the answer is updated to 90 as well. Hence, in the end, the maximum product subarray will be equal to 90. Now, the time complexity of this approach is O of n because we go through each element in the array only once. And in terms of space complexity, it will be O of 1 because we are using few variables like maximum product, minimum product, and answer to keep track of values. Here is a quick code walkthrough of the algorithm we just talked about with Java code on the left and Python on right. First, let's initialize the maximum, minimum, and answer to the first element of the input array. Then we will iterate through the array starting from the second element. And now we have to calculate the maximum and minimum product we have seen so far. But before updating the maximum product, we should store the maximum product in a temporary variable because the minimum product will be needing it. Now the new maximum product will be maximum of the number itself, the product of the current number with the previous max product, and the product of the current number with the previous min product. In Java, the max function takes 2 arguments. So because of this, we have to call max function twice. But Python has a beautiful syntax here because in Python, we can pass the 3 arguments together to the max function and get the maximum. Similarly, the new minimum product will be equal to minimum of current number itself and the product of current number with the previous max product and product of the current number with the previous min product. Now we will update the global maximum product, which is our answer from the max product. And once we are done with all the elements in the array, we will return our answer. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.